Okay. The quantitative aspect of solutions. Now I've separated these videos into one, the qualitative one and the quantitative one. You can kind of keep them separate. Now, if I've got what's the difference between these two? You got a beaker, 2-liter beaker of water with 5 sugar molecules in it versus another beaker of water with 10 sugar molecules in it. What's the difference between these? Which is sweeter? Which is more concentrated? Or more sugar? We count in chemistry referring to mole something. Basically, we have 5 moles of sugar included in water, 10 moles of sugar included in the water, which is going to be more concentrated. 10 molar, is that molar? So the molar aspect is measurement of concentration. So molarity, again, is the measurement of concentration. The units of molarity are that's an uppercase M. I put a line in there because normally it's italicized. Uppercase M. Now remember, one of the last was 3M HCl. 3M is 3 moles. 3 moles. 1 liter. So tonight I want to talk about, there are a lot of examples of tackling malaria. And then on Tuesday, make up solution. Make up the dry ingredients. Okay, so let's look at some examples. So what is the molarity if we have 30 grams of sodium chloride and 2.0 liters of water? Hey, 3.0 grams and 2.0 liters. Okay, looking at the definition of molarity, it's mole solute. What's the solute here? The salt or the water? Salt. So we need the moles of salt. We need to convert the 3 grams to moles of salt over, and this is per 1 liter. Okay, so we take the 3.0 grams and sodium is 3.2. Okay, so yeah, that'll give us moles. All right. So to find the molarity, first we convert to moles and divide by the volume. And so that's 26 mole. I flipped it. Yeah, this is exactly. Let me just change it. Right. Fine. All right. So the way you'd read this would be I know 26 molar solution. Okay, so does that calculation make sense? Always working with moles. Okay, so let's do one slightly different. Let's stick with the salt and yeah, so just now, how much total for the part? You get 7 grams from the part for the mole, all of the liters. Okay, instead of saying 2 grams of sodium chloride is added to let's do this one Tuesday. I was going to say 2 grams of sodium chloride is added to 5 grams of calcium chloride. What's the sodium molarity? Let's leave that one for Tuesday. Okay. Okay, kind of going the opposite way. How many grams of sodium chloride are in 3 liters of 2 molar solution? We need to get to grams, right? Hmm? What's the best way to do? Distinguish a relationship. Right. Yeah, let's look at the unit. Let me show you a relationship that's very important. If we look at definition of molarity is moles per liter, right? If we multiply what do we get? Think about liters again. I mean, units again. Moles, because liters cancel gives us moles. We multiply the volume times the concentration, we always get moles. Think of MB. M is in volume, M is in molarity, V is in liters. So MV or ML equals moles. And once we have moles, then we get grams. The old fact, right? No. Molar mass, exactly. It would be the what's the molar mass I came up with for 5764? Is that what you said? Yeah, that. Okay, so let's go back to here. This is going to be a 2-step problem. Conceptually, you can put it all in one step. Think of it as 2 problems. First is get moles. We're going to get moles by taking the 2.0 molarity times the 3 liters. That gives us moles. Once we get moles, we take the moles and then convert that to grams. Yeah. I don't know. I haven't done the calculation. So how many moles are we end up with here? 6. Okay, so we're going to take 60 moles. Convert that to grams. We're going to take the 60 moles times the 5764 grams. Is that the calculation you just did? What'd you get? And sig fig wise, what's your real answer? Yeah, 2 sig figs, 350. So there are 350 grams of sodium chloride in 3 liters of 2 molar. Okay, let's do okay, directions. How would you make 5 liters of 2.0 sodium chloride solution? alpha grams. How would you make it? How would you make it? It's more like the rest. How would you make it? Big out the water and salt. What's the first step? Yeah, we need to find out the mass of the salt to start with, right? Okay, so step one is mass. Mass of the salt. Do that by what we just did. Okay, so we're going to go 5 liters times 2 molar gives us what? The moles of sodium chloride times the molar mass gives us 576.4 grams. And sig fig wise, that would be what? 580. Okay, so step one is we know how much salt we need, right? What do we do now? What about the water? How much water do we need? That's right. What is it? 5 liters, right? Sorry, I didn't mean it to be hard. Okay, so tell me how in a recipe instructions, what would your instructions say? Okay, so one solution is the recipe is right? This is what you said, right? Okay, so we're going to dump in 580 grams of salt, 5.0 liters of water. Okay, go in here on the other side. I'm taking it down. What's the first thing you do? Draw the water. When you get in the water, what happens? The water goes up, doesn't it? So if you get into, you draw your water and say it's 30 liters, when you get in, is it still 30 liters?
Yes.
It's going to be more, right? It's no longer 30 liters. But what do we want is 30 liters? It's a problem. Same as this problem. So the second way to make this is something smaller than 5 liters, like say 2 liters. But it can be 3 liters or 4 liters, just not 5 liters. Totally mix it up. It's totally dissolved. Then bring the final volume up to 5. That's the official way. If we add 5 liters of water, we end up with a solution of maybe 6 liters, not 5. So here, but a problem is we want 5 liters. And we all have 5 liters. We want. What we do is we're mixing something less. Less than 5. 2 or 3 years, doesn't matter. It's got to be less than 5. And then when it's totally dissolved, we'll bring the final volume up to what you want. In this case, 5. That makes sense? That's what part we need is first. You put salt in, it'll split, it brings up the water volume. Okay, well, that's what I wanted to cover tonight. I wanted you to feel comfortable with making solutions, certain concentration, being able to figure out how to make them, directions. On the test, I'm going to ask you for directions, and that's B. And I give you a certain concentration and a certain volume, they will come in grams of solute. You should be able to describe the process of dissolving a solid in liquid. You should tell me the parameters of solubility, what makes something dissolve more or less. Remember those three: temperature, physical agitation, and okay, let me end this here.